Welcome. In this video lecture, we are looking at the book Think Python, How to Think Like a Computer Scientist. We're looking at the second edition. The authors are Alan, Jeffrey, and Chris. I'm going to be doing video lectures. My name is Arthur Solomon. I'm going to be working with you throughout these videos. Thank you. Exercise 7.1. General description is essentially, we're going to be copying section 7.5 out of our book. We're encapsulating it with the my_root function, and we should be able to write a loop that will do what's kind of displayed below. Again, it should be called the test_square_root, and it prints out this type of output. And you'll notice essentially it has 4 columns. The first 2 rows are headers, and it's the remaining 4 rows, the remaining 4 columns, rows 3, 4, 5, 6, 7, 8, 9, 10, and 11 are whole numbers, and then the square roots, and then the math square root function, and the differential. So, with that said, let's go ahead, let's jump in, and let's see what we can accomplish. Alright, so first of all, we know we're using the math function, so we're going to import math. Also, I'm going to go ahead and document what I'm doing, so we are doing a loop for determining and comparing square roots. Alright, so the first function we are using, my_root function, sqrt, just like it is out of the book. So def. So we're going to be setting x is equal to a divided by 5. Alright, so, sorry, I don't know why I did divided by 5. X is equal to a, because we want to pass in a variable, which is called a. We're setting that to x. We're doing a while loop, so while the answer is true, we want to do specific functions. So while true, the formula for determining the square root is y equals x plus a divided by x. All of that divided by 2. So this formula we pulled out of the book. What we want to do is we want to run through the formula if there's a correct response. We'll do an if statement. So if y is equal to x, we will return the value of x. If not, x will then equal y. And again, that portion, we're just taken directly out of our module 7.5 for our square root formula. So that will define our basic square root function. I forgot the colon up there. So forgot the colon at the if statement, forgot the colon at the function. Alright, so now we have our test function. It was test square root and we are passing in. First number we are starting with will be 1.0, so we're setting the first number equal to 1. We will do another while loop. So while a is less than 10.0, So why 10.0? Because the book was very clear. It was 1.0 through 9.0. So that's why we're doing this while loop. We set the variable 1.0 and we want it less than 10.0. You can do this multiple ways. You can do less than or equal to 9.0, but how you do that's not really as important as understanding of why we're doing that range. Alright, so I want to set up our table. So we're going to do a print function. So I didn't want to type it out, so I just copied it. So print, we are printing A. We're printing the square root of A. We are doing the math square root of A. We're doing the absolute value between my square root A minus the math square root of A. These parentheses close up that. This parenthesis closes up with that. So we have to make sure we have some type of incrementing function. So A will be plus equal 1. Now remember, this just means A is equal to A plus 1. That way each time the loop goes through, it will process that. And for our function, basic functionality, we are taken care of. So let's go ahead, let's do a function call. And let's see if it works. While true, my keyboard today is just funky as all heck. So we have our first set of numbers. 1 is 1, 1, 1. 2 is that. Alright, so let's compare it to what we are supposed to be getting. So I will open up a new notepad. So I left that line of code in there so that we know kind of the responses. So I understand the formatting right now is not correct. That is okay. What I'm most interested in is the math function. 1, 1, 1, 0. Alright, there is a differential. So 2.22044 406 406 925E. See, this one adds in additional decimal places. So again, I mean, realistically, I would still call this a win. Decimal places aren't identical, but that's more for formatting. But I mean, for the most part, we got it. So if you're the type of student that can see the purpose of that loop, we're good. However, if you do want to go further, if you do want to make this more identical to the example, then let's keep going. Alright, so what we're going to do is underneath A, I'm going to do a print. And what I'm going to do is I'm setting the right justify. That way I can have the spaces that I need that are appropriate. And then here you'll notice again, this is all one big print. And so this will line up a little bit better. So I'm actually going to clear it. So, I mean, we have our formatting now. Responses are still not quite as precise as, a lot of people would like, but the output is looking way similar to what we would be expecting. So I'm going to go ahead, I'm going to comment out these two lines. And I'm going to paste in a new set of print lines. So all I did was I'm printing out a dash, I'm timing it by the appropriate number of characters they should be there. I'm also printing out, you'll notice in single quotes, like A, the spacing and whatnot. So I'm going to run this. That way my titles are more aligned, and the amount of dashes underneath them, like here we have 9 dashes, that's because we have dash times 9. We have 3 blank places, and then we have our math square root. I just did the count for that, and then I did the count for that. So this is way more than sufficient if you wanted to stop here. If you want to keep going, if you want to be specific and match identical this example, again, this was out of the exercise at the end of the chapter. If you want to do that, a while loop is not as easy to do this. Also, we can do it with for loop, which I'll show you how to do that, but we're going to have to take and separate out the decimal places. First, the decimal place to the left and the decimal place to the right, and we'll have to do this as an individual number basis. We'll walk you through it just in case. Alright, so I will clear, and I'm going to create a new module. That way I could be working with my new module as I'm working through this. Alright, so for this one, we're again import math. But this time we need to also declare a new variable, a global variable, something that's going to be used throughout all functions. So we're going to be creating a variable called epsilon. 1, 2, 3. So epsilon, from the end of module 7.5, we're talking about being able to verify the numbering. So again, from the last line in 7.5, it reads, for most values of this work is going to be fine, but in general it's dangerous to test floats equality. So floating point values are only approximate rightmost rational numbers, like 1/3, and irrational numbers like the square root of 2. They can't really be represented exactly with a float. So with that said, rather than checking whether x equals y, or exactly equal, it's safer to use the built-in function abs, to compute the absolute value or the magnitude of the difference between them. So for that, we'd be doing the calculation if abs y minus x is less than the epsilon. Again, epsilon is going to be the smallest value number we can go with. We're not doing 0, we're doing 9 zeros. That's 3, 4. That's 3, 4, 5, 6, 7, 8, 9 zeros, and the 10th place is a 1. So again, we're still an extremely small number. Alright, so our function. So I'm going to go ahead, I'm going to copy over the square root function we had earlier. So while x equals a, that's fine. We can keep the while true portion because we pulled that from our textbook. So what about this if statement? Does this if statement work? For what we're trying to do now, not really, because we're not supposed to be comparing the two variables. Not like this, at least. So what we're going to do is if, I will get rid of that, the absolute value y minus x is less than epsilon, we will return the value of y. Don't forget the colon at the end. And then we will go ahead and break this loop. Else y is equals, or x is equal to y. So again, it's very similar to what we did, except we are following the rule at the very end of 7.5. Alright, so that took care of our first function. Well, the problem is, I already said, if we're trying to make it identical to the book, we have to separate out the left and right digits. So I'm going to create a new function. I'm going to call it right digit. And I will have it pass in a variable. So from there, I'm going to limit the amount of characters. So I'm actually going to use a trunc command, TRU, and I'm going to set that equal to, alright, I'm going to set that equal to a float where it's going to be in dot 11 f single quote. And again, the trunc is just a variable. It's not a function that's predefined or anything. It's just we can name it whatever we want. I'm doing that because when I was shown how to do this, that's the way that we've always had it done. So in my coding experience, that's what I've done. So my dig is going to be my trunc and that is actually going to be set to the length, and that will be of my trunc, and I'm going to minus 1. I will return the dig, and essentially this will take a floating point number and return its rightmost digit in the string format. So this is where it gets a little more complicated because we're starting to change our different variable types. Alright, so now we will do our test square root. And I already liked I will copy this over. I already did all the counting for my prints, so I'm going to keep my prints. They do have to be tabbed over though. So print A, yada yada yada, square root of A, math square root of A, and the difference, and then the appropriate spaces. Alright, so this is where we started doing our loop for our calculation. Again, you can use multiple loops It just really depends on the individual. I'm going to use a for loop now instead. So I will do for when my integer is in the range 9. Basically what that says is my variable, as long as it is in the range 1 through 9, it's good. Y will be equal to I plus 1. Yes, you can do this other multiple ways. You could declare I first to 1. You can use different variable names. We could be doing I plus, or I is plus equal to 1 and then use I. Again, multiple ways to do this. So if you modify this a little bit, not that big of a deal. It's just, I'm just showing you how I did it. I will be doing a print statement. I will be formatting it. Alright, so what is this right here? How is this formatting? Well, I'm doing a fixed length for my prints. That way my numbers aren't all over the place. That is why I'm doing the :0.1 F. I'm setting fixed lengths to my prints. Alright, so with that said, that's the first line. Now we need to actually do our calculation portion. So if my square root x, we will be minusing the integer value of my square root of x. Oh, I think I did one too many parentheses. Alright, that's good. And we want all of that to be greater than, sorry, we want that all to be less than 0.001. That way we can keep our numbering a little bit tighter. If that is the case, y is equal to 1. Else if, this is where we're going to start calling a different variable. So our right digit my square root x, and the assumption is, sorry, if it is equal to 0, y is going to be set to 10. Else, y is set to 11. And again, this is, we're still just dealing with our spacing. Alright, so next we will actually now print our functions. So we will be printing our value, and we will be setting a specific fixed length. That way our numbers aren't all over the place. Alright, so now we need to talk about our diff. Here our diff is going to be set to our math.square root minus the square root function we have. So we want to see if there's a difference. And again, we are doing our diff to a very specific decimal place. Alright, so we will go ahead and test all of this to see test square root we're going to be passing in the variable 9. Well, let's see if it works. So, I don't know why I made a copy of it. I gave test square root 9, and I actually, when I did that, I forgot to say that I was putting in a variable. So here, it's variable as it comes in. Let's try that again. I'm going to clear it. I will run it one more time. And I will bring up our requested so our numbers are matching. Now, okay, granted that the spacing between the columns are not as good as they could be, but I mean, that is outside what we're doing at this moment. Right now, we're just comparing, are they similar? And they are. We have our lining up. We have our columns that are lined up. We have our rows that are set to the correct decimal place. So we are good. Am I expecting you to be able to do this level of precision? No. Again, understand the purpose of this course. This is more getting you the exposure, but I was asked to do one video that covered an acceptable level, something that was simple, down and dirty, that would work, and one that would be pristine, like what would be acceptable in a more advanced course. So that covers our loop for section 7.5 in our textbook, and it provides a similar output as described at the end of the exercise, at the end of the chapter exercise. Questions, comments, anything, please reach out. I know especially with this, because I did the basic and the more advanced coding, the advanced coding might be more of a struggle, but if you have any questions, again, reach out, let me know. That concludes this chapter. If you have any questions or concerns, please feel free to reach out and leave me a comment or a question. I'll try to get those answered as quickly as I can. Again, thank you, and I look forward to working with you in later modules.